The population of a bacteria colony starts at 100 bacteria and grows by 30% per hour. I'd like for you to find a formula for the number of bacteria P after T hours, and then use logs to find the continuous growth rate of the colony. Okay, so this will be pretty similar to what we did on the previous page, and then I'm going to help you with part B, the doubling time. All right, so pause the video, give those two a quick try. All right, so our formula here, it doesn't say that it's growing continuously. In fact, it says per hour. So we know that that's going to require the form Q is equal to AB to the T. And B is 1 plus R. And R is this 30%. So we'll convert this 30% to a decimal. So 0.30, which gives me B is 1.30 or 1.3. So my formula here, my A is going to be 100. That's my starting amount. So my formula is Q is 100 times 1.3 raised to the T. And then to get our continuous growth rate, we know that B is equal to e to the k. So 1.3 is equal to e to the k. And I'll apply the natural log to both sides here. And when I do that, that natural log of e to the k, since ln and e are inverses, that just gives me k. So k is approximately equal to 0.2624 or 26.24%. Right, and then let's take a look at B. So it says, what is the doubling time for the population? That is, how long does it take for it to double in size? So that means we're going to need to solve for T in this equation if we're looking for how long it takes. And that means we need to fill in something for Q so we can solve for T. If we're looking for the time it takes to double in size, and it starts at 100, the doubled size would be 200. So we're looking to solve 200 is equal to 100 times 1.3 to the T. And we solved these before graphically, but now we're going to solve them using logs here. Okay. So I'll divide that 100 over so I can isolate this piece with the T. So 200 divided by 100 is 2, is equal to 1.3 to the T. Okay, you can use ln or log here. I use ln all the time, so that's what I'm going to go with. I'll apply ln to both sides. And what that does is I can use that law of logs to bring that t down in front. I get ln of 2 is t ln of 1.3. And then I can divide this ln of 1.3 to the other side. So t is ln of 2 divided by ln of 1.3. And that comes out to be approximately, let's see, ln of 2 divided by ln of 1.3. So about 2.64 hours since we're measuring t in hours. All right, come back and we're going to take a look at the half-life instead of the doubling time.